There is a map of the world almost everyone carries in their head. North America is cold. Europe is old, crowded, civilized, and somehow mild. London has rain. Paris has calves. Amsterdam has canals. Scotland has green hills. Norway has fishing villages beside dark water. But if you take those places and slide them straight west across the Atlantic, without moving them north or south, the picture starts to break. London sits around the same latitude as Calgary. Paris is farther north than most people in Canada. Edinburgh lines up not with New York, not with Boston, not even with Montreal, but with the far northern edge of Labrador. And much of Scandinavia sits in the same band of the planet as Alaska, Yukon, and northern Canada. So the question is not why Canada is cold. The question is why Europe is not. Because latitude does not care about culture. It does not care about cathedrals, capitals, vineyards, ports, or history. Latitude is geometry. And by geometry alone, much of Europe should feel far more like the edge of the Arctic world than the comfortable continent we know. Something is cheating the map. Something is moving heat across an ocean, not as a storm, not as a season, not as weather, as a machine. A slow, silent, planet-sized machine hidden beneath the surface of the Atlantic. For thousands of years, it has helped keep a continent livable. It has shaped rainfall, farming, fisheries, coastlines, trade routes, and the quiet assumption that tomorrow's climate will look enough like yesterday's to build a civilization around it. Most people never see it. Most people never think about it. But every winter in Western Europe, every growing season, every port, every city that exists farther north than it feels like it should, is living inside its shadow. And now, measurements and models suggest that this machine is weakening. Not like a disaster movie, not all at once, but in the way the most important systems often fail, slowly, quietly, mechanically, until the thing that always worked no longer works the same way. So what happens to Europe, to America, and to half the world when the machine that keeps Europe alive begins to shut down? To understand this machine, start with the Atlantic. Not the Atlantic as a flat blue space on a map, the Atlantic as a moving engine. At the surface, warm water leaves the tropics and begins traveling north. It starts in the sunbelt of the planet, where the ocean is heated day after day by tropical sunlight. Some of that water moves through the Caribbean, some passes through the Gulf of Mexico. Then it exits near Florida and begins racing up the eastern edge of North America. This is the part most people have heard of, the Gulf Stream. But the Gulf Stream is not the whole machine. It is only the visible belt at the front of a much larger system. The full system is called the Atlantic Meridional Overturning Circulation, AMOC. The name sounds technical because it is describing exactly what the ocean is doing. Atlantic, because the main basin is the Atlantic Ocean. Meridional, because the movement runs north and south. Overturning, because the water does not simply move across the surface. It turns over, it sinks, it changes levels. And circulation, because this is not a one-way trip. It is a loop. That is the first thing to understand. The AMOC is not just a current. It is a circulation. Warm water moves north near the surface. Cold water returns south in the deep ocean. And between those two movements, an entire climate system is quietly organized. Picture the Atlantic as a giant vertical loop. On the top of the loop, warm surface water flows northward. It carries heat out of the tropics, past the eastern coast of the United States, toward Newfoundland, across the North Atlantic, and into the waters near Greenland, Iceland, and Northern Europe. As it travels, it gives heat to the air. That heat does not stay politely above the ocean. Winds pick it up, Weather systems carry it east. The atmosphere spreads it across Western Europe. This is why a city at the same latitude as parts of Canada can have rain instead of months of deep freeze. The ocean is not just sitting beside Europe, it is delivering heat to it. A continent is being warmed by water that began far away, under a stronger sun. But the delivery is only half the story. Because the machine cannot keep moving north forever. At some point, that warm water reaches the far North Atlantic and the environment changes. The air becomes colder. The storms become harsher. The ocean loses heat. And as the water cools, it begins to transform. It becomes heavier. Not heavier in a poetic sense, physically heavier. A cubic meter of that water begins to weigh more than the water around it, and when ocean water becomes heavy enough, it sinks. This sinking happens in key regions of the North Atlantic, especially around the seas near Greenland, Iceland, and Labrador. That sinking is the hinge of the whole machine. Because when surface water sinks, it creates space at the surface. That space has to be filled. So more warm water is pulled north. Then that water cools. Then it sinks. Then more water follows. This is the rhythm. Warm water north, cold water down, deep water south, surface water north again, over and over. For generations, for millennia. Once the cold water sinks into the deep, it begins the second half of its journey. Now it is no longer a warm surface current. It is a deep, dense current moving southward in darkness, far below the waves, beneath the ships, beneath the storms, beneath almost everything human beings normally see. It travels down the Atlantic basin, past the equator toward the Southern Ocean. There, around Antarctica, the Atlantic connects into the wider global ocean system. The water can be mixed, lifted, transformed, and eventually brought back toward the surface. Then, over long periods of time, it can begin the journey again. This is why people sometimes call it the global conveyor belt. That image is not perfect. The ocean is not a simple mechanical belt. It bends, branches, slows, accelerates, and changes with winds, seasons, underwater mountains, salinity, temperature, storms, and the rotation of the Earth. But as a mental picture, the conveyor belt is useful because it captures the important idea. The ocean is not still. The ocean is carrying things. Heat, salt, carbon, nutrients, momentum, and time. The surface current you see in one place is connected to a deep return flow somewhere else. The warmth delivered to one region is tied to the sinking of water in another. The climate of a city is tied to the density of water hundreds or thousands of miles away. This is the hidden structure. And it is why the Atlantic matters so much. Most oceans move heat from the tropics toward the poles. That part is normal. But the Atlantic does something special. It moves a large amount of heat across the equator, from the southern hemisphere into the northern hemisphere, and pushes that warmth deep into the North Atlantic. That means the Atlantic is not just redistributing heat inside one half of the planet, it is helping balance heat between hemispheres, like a pump. And the pump has consequences. If the sinking regions are strong, the whole loop pulls harder. If the sinking regions relax, the loop does not pull the same way. But before we talk about weakness, we have to respect the engineering. Because this is not a small system. The AMOC moves water on a scale that makes human infrastructure look almost imaginary. It carries heat northward through the ocean, not in pipes, not in power lines, not in tankers, but through physics. A planetary heat delivery system with no control room, no switch, no owner, no maintenance crew, just sunlight, salt, cold air, gravity, wind, and time. And the reason Europe feels the way it feels is not because Europe is protected from geography. It is because geography has an oceanic partner, The land is where people live. But the ocean sets many of the terms. A farmer in Ireland, a fisherman in Norway, a port operator in the Netherlands, a family heating a home in Britain, a vineyard in France, a winter storm forming over the Atlantic. All of them are connected to this slow loop of water. Not every day, not in every storm, not in a simple one cause, one effect way, but structurally. The AMOC is part of the background condition that makes the modern North Atlantic world recognizable. It is one of those systems so constant that people mistake it for the natural order of things. But it is not a guarantee. It is a process, and every process depends on rules. Warm water must move north. It must lose heat. It must become dense enough to sink. Deep water must return south. Surface water must continue replacing it. That is the loop. That is the engine. That is the map hidden beneath the map. And once you see it, Europe stops looking like an exception. It starts looking like the endpoint of a delivery route. The tropics produce the heat. The Atlantic carries it. The far north processes it. The deep ocean returns it. And the air above Europe receives the benefit. This is how the machine turns, quietly, continuously, almost invisibly. But the most important part of the machine is not the water itself. It is the rule that decides whether water floats or sinks. The ocean machine runs on a rule so simple that it almost sounds too small for the job. Some water floats, some water sinks. That is the arithmetic, not the politics of it. Not the emotion, not the headline, the arithmetic. Ocean water has density, and density is shaped mostly by two things: temperature and salt. Warm water is lighter, cold water is heavier, fresh water is lighter, salty water is heavier. Put that together, and the rule becomes easy to remember. Cold, salty water wants to sink. Warm, fresh water wants to stay near the surface. That is the quiet equation beneath the Atlantic. Not an equation written on a chalkboard, an equation written into the movement of the sea. Every time warm tropical water travels north, it begins to lose heat to the colder air above the North Atlantic. As it cools, it gets denser. And in the far northern seas, another thing happens. Sea ice forms. When seawater freezes, most of the salt does not go into the ice. The ice is comparatively fresh. The salt is left behind in the water around it. So the surrounding water becomes saltier, and because it is now colder and saltier, it becomes heavier. Eventually, in the right places, it becomes heavy enough to fall. Not like a stone through the air, more like a slow collapse through the layers of the ocean. The surface water sinks into the deep, and when it sinks, it does more than move downward. It pulls the system behind it. Think of it like a line of people walking through a doorway. If no one exits, the line stops. But every time someone passes through the door, space opens behind them. More people move forward. The sinking water is the doorway. When dense water drops into the deep Atlantic, it creates room at the surface. That room is filled by more warm water moving north. That water cools. It grows denser. It sinks. And the line keeps moving. This is why the AMOC is not powered by one thing. It is not only wind. It is not only the Gulf Stream. It is not only the shape of the continents. It is the combination. Wind helps push water around the surface. The rotation of the earth bends the flow. The coastlines guide it. But the overturning, the part where the ocean turns from surface current into deep return flow, depends on density. And density depends on the balance between heat and salt. That balance is delicate, not fragile like glass. Fragile like a lock. A lock can be made of steel. It can last for decades. It can seem unbreakable. But if the pens inside it no longer line up, the door does not open. The Atlantic works the same way. The ocean does not need to vanish. The Gulf Stream does not need to disappear. The waves do not need to stop. The visible sea can look almost exactly the same from the deck of a ship. But if the density structure changes enough in the wrong place, the deep part of the machine can stop pulling with the same force. And once that begins, the problem can start feeding on itself. This is the part that matters. A strong AMOC carries warm, salty water north. That salty water helps the Northern Ocean become dense enough to sink. So the machine strengthens the conditions that keep the machine running. It delivers salt to the place where sinking happens. But if the AMOC weakens, it carries less warm, salty water north. Less salty water arrives in the sinking regions. At the same time, fresh water can build up near the surface. Fresh water from melting ice. Fresh water from rainfall. Fresh water from rivers. Fresh water that does not behave like the salty water underneath it. Because fresh water is lighter, it tends to sit on top. It acts like a lid. Below it, the ocean may still be cold, but the surface layer is now more buoyant, less eager to sink, less willing to open the doorway. And if less water sinks, less warm, salty water is pulled north. If less salty water is pulled north, the surface becomes fresher. If the surface becomes fresher, less water sinks. And if less water sinks, the machine weakens again. That is the feedback loop. Not a prophecy, not a movie, a mechanism. The thing that weakens the system can also reduce the system's ability to repair itself. This is why scientists speak carefully about thresholds. A threshold is not the same thing as a deadline. It is not a date circled in red on a calendar. It is a boundary in the behavior of a system. On one side, pressure can build and the system still returns. It bends. It fluctuates. It absorbs shocks. It moves within a range. But on the other side, the same system can begin moving toward a different state. A weaker state. A slower state. A state that is not easily reversed. That is what people mean by a tipping point. The phrase is often used badly. It gets thrown into headlines until it starts to sound like theater. But in a physical system, the idea is plain. Imagine a chair tilted back on two legs. At first you can lean and recover. Lean a little more and recover. Then, at one point, nothing magical happens. No alarm goes off. But the center of weight crosses a boundary, and from there, the fall has already begun. The Atlantic does not behave exactly like a chair. But the lesson is useful. The danger is not that the system changes. The climate system has always changed. The danger is that some changes can push a slow machine past the range where it naturally returns to the old pattern. And because the AMOC is so large, so deep, and so slow, that return would not be measured in election cycles. It would not be measured in news cycles. It may not even be measured in human lifetimes. The ocean remembers. A molecule of water can take centuries to complete the full conveyor. The surface can react in seasons. The deep ocean answers in ages. This is also why uncertainty is part of the story. Not all measurements cover the same period. Not all models agree on the same timing. Not every scientific group places the threshold in the same place. Some studies suggest the system is more stable than the most alarming interpretations imply. Others suggest the warning signals are stronger than older models captured. Both positions can exist because the ocean is hard to measure, and because the deep Atlantic does not give up its secrets easily. That does not mean nothing is known. It means the known part and the unknown part must be kept separate. The known part is the mechanism. Warm water moves north. Cold, salty water sinks. Deep water returns south. Density drives the overturning. Freshening the surface makes sinking harder. Weakening the sinking can weaken the pull. That is the engineering. The debated part is the margin. How close the system is to a threshold. How fast it could approach one. How much weakening is temporary variation, and how much is structural change. Where exactly the point of no return sits. Those are not small questions. They are the questions. But the existence of uncertainty does not erase the machine. It only tells us that the machine is operating in a part of the planet where the gauges are still incomplete. The honest answer is not to pretend the plane is already falling. And it is not to pretend there is no risk because the cockpit is complicated. The honest answer is to understand the engine. Because once you understand the engine, the numbers begin to matter. Not as decoration, not as panic, as evidence. The Atlantic machine depends on the ability of northern waters to become dense enough to sink. Add heat, and the water becomes lighter. Add fresh water, and the water becomes lighter. Slow the delivery of salt, and the water becomes lighter. Less sinking, less pull, less transport, less salt delivered north. More weakness feeding more weakness. This is the arithmetic of the AMOC. And it is the reason the next part of the story does not begin in a computer model. It begins in the past, because the planet has already run this experiment before. The Atlantic has not always behaved the way it behaves now. That is the part that changes the story. Because if the AMOC were only a modern fear, only a projection, only a line inside a climate model, it would be easier to dismiss. But the planet has a memory, not written in books, written in ice, written in mud, written in pollen, shells, lake beds, ocean sediments, cave formations, ancient shorelines, and the chemistry of water that froze before any city existed. And in that record, there is a warning. A version of this pattern has happened before. At the end of the last ice age, the world was warming. The great ice sheets that had covered huge parts of North America and Europe were retreating. Sea levels were rising. Landscapes that had been locked under ice were opening again. The planet was moving, slowly but clearly, out of a frozen age. Then something interrupted it. About 12,800 years ago, the northern hemisphere suddenly lurched back toward cold. Not a mild cooling, not a bad winter. A return toward near glacial conditions across large parts of the North Atlantic world. In Greenland, ice records show a dramatic fall in temperature. In Europe, forests retreated in many regions. Cold, adapted plants spread into places that had been warming. The climate became colder, drier, windier, and it did not last for one season. It lasted for roughly 12 centuries. Long enough for generations to be born, live, and die inside a climate their ancestors had not expected. This period is known as the Younger Dryas. The name comes from a small Arctic alpine flower whose fossil remains were found in cold climate layers of European sediment. But the name is less important than the pattern. The world was warming. Fresh water entered the North Atlantic system. The ocean circulation weakened. Heat stopped moving north in the same way. And the climate reorganized. That is the chain that matters. The exact trigger is still debated. It probably was not one clean switch pulled by one clean cause. The Earth rarely works that neatly. One leading explanation is that enormous volumes of fresh water escape from melting ice sheets and glacial lakes in North America. This fresh water reached the northern Atlantic or connected Arctic pathways, spreading over the saltier sea like a lid. And because fresh water is lighter than salty water, it made the surface harder to sink. The doorway began to close. The overturning weakened. Less warm water moved north. Less heat reached the North Atlantic. The cold expanded. This is the same arithmetic from the last block. but now written into history. Cold, salty water sinks. Warm, fresh water floats. Add enough fresh water in the wrong place, and the sinking can slow. Slow the sinking, and the machine loses pull. Lose the pull, and the heat delivery weakens. We do not have to imagine that rule. The Earth has already shown it. The younger Dryas is not a perfect copy of the modern world. That point matters. The ice sheets were different. Sea level was different. The continents were emerging from a glacial age. The atmosphere was different. The world was not filled with ports, highways, power grids, grain markets, container ships, coastal cities, and billions of people. So the younger Dryas should not be used like a prophecy. It is not a script. It is a stress test. It shows that the North Atlantic circulation is capable of changing abruptly when the physical conditions around it change. It shows that the climate system has thresholds. It shows that fresh water can matter. And it shows that a regional disruption in the Atlantic does not stay politely inside the Atlantic. When the North Atlantic cooled during the younger Dryas, the consequences reached outward. Rainfall belts shifted. Monsoon patterns weakened in parts of the northern hemisphere. Tropical regions registered the change in caves, marine sediments, and other natural archives. The atmosphere responded to the ocean. The ocean responded to ice. The ice responded to temperature. And the whole system moved as one connected machine. This is why the past matters, not because the future must repeat it exactly, but because the past proves that the mechanism is real. A weakening Atlantic overturning circulation is not an invented danger. It is one of the known ways the climate system can reorganize itself. And when it reorganizes, it does not ask whether human systems are ready. There is a popular image many people already carry for this subject. A disaster film from 2004, the one where ocean circulation collapses and a new ice age arrives almost overnight. People remember the frozen cities. They remember the idea that the Atlantic could simply shut down and throw the world into instant catastrophe. That is not the real story. The real AMOC does not behave like Hollywood. The ocean is too large. The deep water is too slow. The atmosphere is too complicated. The world does not freeze in a weekend. But once you remove the movie, the real story becomes more unsettling. Because the realistic version does not need spectacle. It does not need an instant ice age. It only needs the quiet weakening of a system that modern civilization assumes will keep doing what it has always done. A little less heat delivered here. A little more sea level rise there. A rainfall belt shifted south. A monsoon weakened. A growing season shortened. A fishery displaced. A coastline made more vulnerable. A continent losing the invisible subsidy that helped make its climate feel normal. That is the difference between fiction and mechanism. Fiction needs a moment. Mechanism needs a threshold. And thresholds are harder to see. A storm announces itself. A tipping system usually does not. It can look stable for a long time. Then it can look strange. Then it can look unstable. And only afterward do people realize that the most important change was not the day everything broke. It was the long period when the machine was being pushed toward a new state. The younger Dryas teaches humility. The record is powerful, but incomplete. Scientists can read the chemistry of old ice, but they cannot place instruments into the ocean of 12,800 years ago. They can reconstruct temperature from proxies, but proxies are not thermometers. They can model freshwater pulses, but models are not the planet itself. Some research emphasizes a freshwater shock and a weakened AMOC as the central cause. Other work suggests the younger Dryas was more complex, with atmospheric circulation and other forces working alongside the ocean. That does not weaken the story. It makes it honest. Because the lesson is not that one ancient flood flipped one ancient switch in one simple way. The lesson is that the Atlantic circulation sits inside a larger climate machine, and when that machine is disturbed, the consequences can travel farther, last longer, and arrive faster than a stable society expects. The past does not tell us the exact date of a future collapse. It does not tell us the precise strength of the AMOC in every decade ahead. But it tells us something basic. The ocean circulation can weaken. Fresh water can interfere with sinking. The North Atlantic can lose heat. Climate zones can move. And a change that begins in the ocean can reorganize life on land. For thousands of years, the modern world has been built inside a relatively stable climate window. Stable enough to plant, stable enough to map, stable enough to insure, stable enough to build cities on coasts and assume the shoreline will remain close to where it was. Stable enough to believe that climate is background. But the Younger Dryas is a reminder from before civilization. The background can move. And when it moves, the world above it has to move too. It would be easy to tell this as a European story. A colder London, a harsher Norway, a different winter in France, Ireland, Germany, and the Netherlands. And all of that matters. But for an American viewer, the first mistake is to imagine that the Atlantic has an eastern side and a western side, and that a problem on one side stays there. The ocean does not work that way. The same machine that helps warm Europe also runs along the American coast. It passes Florida. It shapes the waters off the Carolinas. It moves past Virginia, Maryland, Delaware, New Jersey, New York, and New England. And when that machine changes, the American side feels it too. Not first as snow over Times Square, not first as frozen cities, first as water. Sea level is not a bathtub. When people hear sea level rise, they often picture the whole ocean rising evenly, the way water rises in a glass. But the ocean has slopes. It has pressure patterns. It has currents. It has winds. It has differences in temperature and salt. And large currents can help hold water away from certain coastlines. When those currents weaken or shift, water that was once distributed differently can pile up in new places. Along the U.S. East Coast, this matters. Because the western edge of the North Atlantic is already one of the places where sea level rise can run ahead of the global average. Part of that is land. Part of it is ice. Part of it is warming water expanding. And part of it is circulation. When the AMOC weakens, studies suggest it can accelerate sea level rise along parts of the western Atlantic boundary. That means the American version of this story may begin in places that do not look Arctic at all. Charleston, Norfolk, Annapolis, Miami, New York Harbor, Boston, places where high tide flooding already turns streets into shallow canals on ordinary days. Places where a few extra inches of water are not abstract. They decide whether a storm drain backs up, whether salt water reaches a road, whether insurance gets harder, whether a mortgage becomes riskier, whether a coastal city spends billions on walls, pumps, gates, raised roads, and retreat. A weakening AMOC does not need to create a new ocean. It only needs to change the height of the old one. That is how a current near Greenland can become a budget meeting in Virginia. That is how a density change in the North Atlantic can become a property question in Florida. That is how the invisible machine reaches you. But water on the coastline is only the first layer. The second layer is food. Modern food is not local in the way people imagine. The bread on a table may depend on wheat from one region, fertilizer from another, diesel from another, shipping lanes from another, and rainfall patterns over a continent the buyer will never visit. A grocery store looks stable because the shelves are arranged. But behind those shelves is a global climate machine. Rain at the right time, heat at the right time, rivers with enough water, ports that stay open, harvests that do not fail in too many places at once. The AMOC helps shape the temperature difference between hemispheres. And that temperature difference helps influence where the great tropical rain belt sits. That rain belt is not just a line on a map. It is the zone where warm air rises, clouds build, and seasonal rains are organized across parts of the tropics. Shift it north or south, and whole rainfall systems shift with it. Not everywhere in the same way, not simply, but structurally. A weakened or collapsed AMOC is expected in many studies to push the tropical rain belt southward. That can change rainfall in Central America. It can disturb parts of the Amazon. It can affect West African rainfall. It can alter monsoon behavior. And when monsoons change, food changes. Rice, corn, soybeans, wheat, coffee, cocoa, livestock feed. Shipping routes, import prices, export pressure. A drought in one region is a tragedy. A drought in multiple breadbaskets is a market event. And a market event becomes a household event. It becomes the price of cereal, the price of meat, the price of coffee, the price of insurance, the price of aid, the price of stability. This is why the AMOC is not only a climate story, it is a supply chain story. It is a grocery story. It is a coastal real estate story. It is a military planning story. It is a migration story. It is a quiet risk sitting underneath systems that were built during a period of unusual climate stability. And then there is Europe. Because Europe is still the place where the signal becomes most visible. If the AMOC weakens enough, the North Atlantic loses part of its heat delivery. And if the North Atlantic loses heat, the air above it changes. Storm tracks change. Sea ice changes. Winter extremes change. The first image should not be a Hollywood glacier rolling through Manhattan. The real image is stranger. Imagine the west coast of Norway, famous for dark winter water, facing cold extremes that in some modeled scenarios fall below -40 degrees. -40 Celsius. -40 Fahrenheit. At that temperature, the two scales meet. Imagine Scotland, built around a damp maritime climate, facing winter extremes closer to -30 Celsius in some collapse scenarios. Imagine the Netherlands, a country engineered around water, trade, ports, greenhouses, canals, and low land, facing winters that feel less like Western Europe and more like the edge of the frozen north. Imagine parts of northwestern Europe not simply getting colder air, but seeing sea ice expand southward in winter. Not permanent ice sheets, not a movie ice age. Sea ice, seasonal ocean ice reaching into places that built their modern life around open Atlantic water. The difference is enormous. Open, dark ocean absorbs sunlight. White sea ice reflects it. So once sea ice expands, it can amplify the cooling around it. Less heat stored in the water, more sunlight reflected. Colder air, more ice, a regional feedback. The same kind of logic again. For a country like Britain, the impact is not just whether people need heavier coats. Some modeling of a fast AMOC collapse suggests that land suitable for arable farming could shrink dramatically. The problem is not only cold, it is drying. Less rainfall during the growing season, less land suitable for crops, more pressure on imports, higher costs moving through the food system. That is what climate risk often looks like in the real world. Not one dramatic event. A narrowing of options. A farm that used to work becomes marginal. A crop that used to be reliable becomes risky. A port that used to flood rarely floods often. A country that used to import cheaply starts competing in a tighter market. A winter that used to be annoying becomes dangerous. A coast that used to be insurable becomes expensive. A system that used to absorb shocks starts passing them forward. The danger is not that every place gets worse in the same way. The danger is that the pattern becomes less familiar. Some places cool while the planet overall warms. Some places dry while others flood. Some coastlines rise faster than others. Some food regions lose reliability. Some storm tracks change. Some fish move. Some governments adapt. Some do not. And because the AMOC is connected to both ocean and atmosphere, the consequences do not come with one clean label. They arrive as many different problems that do not look related. A flood map in Florida. A failed harvest in West Africa. A cold emergency in Scotland. A food price spike in the Midwest. A port adaptation plan in the Netherlands. A monsoon shift in South Asia. A fisheries dispute in the North Atlantic. Different headlines, same machine. That is why this story belongs on Beyond the Noise. Because the noise is the headline. The signal is the mechanism. And the mechanism says that a slow current in the Atlantic can touch a home that has never seen the Atlantic. It can touch a person who does not live in Europe. It can touch the American coast, the American grocery bill, the American insurance market, and the American idea that distant climate systems are distant. They are not. They are only hidden. And once a machine like that starts changing, the obvious question is the human one. Can we fix it? Can we push it back? Can we cut the right input, pull the right lever, build the right wall, invent the right technology, and keep the conveyor turning? That is where the story becomes uncomfortable. Because the ocean does not move at the speed of our solutions. Once people understand the machine, the next instinct is natural. Fix it. That is what modern people do. A bridge cracks, we reinforce it. A power grid fails, we repair the line. A river floods, we build higher walls. A disease spreads, we search for a treatment. A market breaks, governments intervene. The modern mind is trained to look for the lever. So when we talk about the AMOC, the question arrives almost automatically. Where is the lever? What do we cut? What do we build? What do we spray into the sky? What do we pump into the ocean? What treaty? What technology? What emergency plan keeps the Atlantic machine turning? The uncomfortable answer is that there may not be a repair lever. There are ways to stop pushing the system harder. There are ways to reduce the pressure. There are ways to adapt around the edges. But there is no known human tool that can reach into the deep North Atlantic and simply restart a circulation that has crossed into a different state. That is not because people are stupid. It is because the machine is too large, too slow, and too deeply connected to physics. Start with the most obvious solution: cut emissions. This is where the subject often becomes political, so keep it mechanical. More heat in the atmosphere means more heat in the ocean. More heat in the Northern Ocean makes surface water lighter. A warmer atmosphere can also intensify parts of the water's cycle, changing rainfall and freshwater patterns. Melting land ice adds fresh water. Fresh surface water makes sinking harder. That is the chain. No villain is required. No speech is required. It is a density problem. Reducing emissions matters because it reduces the pressure on that density problem. It can lower the odds of pushing the machine toward a threshold. It can limit the long-term warming that makes the surface ocean more buoyant. It can slow the background forces that make the AMOC more vulnerable. So cutting emissions is not useless. It may be one of the only real ways to avoid making the problem worse. But it is not the same thing as repair. That distinction matters. If the system is still on the safe side of the threshold, reducing the pressure can help keep it there. But if the system has crossed a point where the feedback sustains itself, less sinking, less salt delivered north, fresher surface water, even less sinking, then stopping the push does not automatically restore the old circulation. It is like pushing a heavy cabinet across a floor. Before it tips, you can stop pushing. After it tips, the fact that your hands are no longer on it does not stand it back up. The ocean is not a cabinet. But the logic of thresholds is similar. Before the line, prevention matters. After the line, reversal may be a different problem entirely. And the ocean does not reverse on human time. The global conveyor is so slow that a parcel of water can take around 1,000 years to complete the journey. Think about that. 1,000 years. Longer than the distance between the medieval world and the modern world. Longer than empires. Longer than any constitution. Longer than any company. Longer than any election cycle by a factor so absurd that comparison almost becomes meaningless. The surface ocean can respond quickly. The deep ocean cannot. The atmosphere can change in days. The deep Atlantic answers in centuries. That is why the phrase "we can fix it later" is so dangerous. Later is a human word. The ocean has its own clock. The second obvious solution is geoengineering. Maybe cool the planet artificially. Maybe reflect sunlight. Maybe manipulate clouds. Maybe remove carbon from the air on a massive scale. Maybe do something bold enough that the charts bend back toward normal. There are serious researchers studying some of these ideas. They are not all fantasy. But none of them is a clean wrench for the AMOC. Cooling the atmosphere does not automatically restore the exact old pattern of ocean salinity, sea ice, rainfall, winds, deep water formation, and hemispheric heat transport. The AMOC is not controlled by temperature alone. It is controlled by temperature and salt, by winds and density, by freshwater inputs, by the Southern Ocean, by the geometry of ocean basins, and by feedbacks that unfold through the whole climate system. A technology that cools one layer of the system could leave another layer changed. A technology that reduces one risk could create another. A technology that works globally might still fail regionally. And a technology deployed late would be trying to steer a machine whose most important moving parts are already deep underwater. This does not mean research should stop. It means humility should start. Geoengineering is not a magic switch. At best, it is a set of risky tools and a room full of moving machinery. The third solution is adaptation. Build seawalls, raise roads, move infrastructure, change crops, expand irrigation, strengthen ports, harden power grids, redesign flood insurance, prepare food reserves, build better early warning systems. This is practical. It is also necessary. If sea level rises faster along parts of the American coast, adaptation matters. If European agriculture loses reliability, adaptation matters. If rainfall belts shift, adaptation matters. If ports flood more often, if storms behave differently, if fisheries move, adaptation matters. But adaptation is not repair either. A seawall does not restart the Atlantic. A raised highway does not restore deep water formation. A drought plan does not move the tropical rain belt back into place. Adaptation helps people survive consequences. It does not necessarily prevent the mechanism that creates them. A city can raise a road, a country can subsidize crops, a port can build barriers. But the AMOC is not one city, one country, or one coastline. It is a hemispheric system. Its effects cross borders without asking permission. A weakened monsoon does not stop at a customs office. A food price shock does not respect a flag. A changed storm track does not care which party controls a government. A coastal flood does not read a budget speech. The fourth solution is waiting. This is the quiet one, not a policy, an instinct. Wait for better data, wait for clearer proof, wait for the models to agree, wait until the signal is undeniable. Wait until the consequences are visible enough that no one argues anymore. In many areas of life, waiting is reasonable. You do not want to overreact to noise. You do not want to spend trillions chasing a false alarm. You do not want to mistake a fluctuation for a trend. That caution is legitimate. And this is exactly where honesty matters. The science does not give one clean answer about timing. Major assessments conclude that the AMOC is very likely to weaken during this century, while treating an abrupt collapse before 2100 as less certain. Some recent studies argue the risk is higher and the warning signs are stronger. Other work argues that some collapse estimates rely on assumptions that may not be robust, and that the range of uncertainty is wider than the most dramatic headlines suggest. That debate is real. It should not be hidden. It should not be flattened into certainty. But uncertainty cuts both ways. It does not prove safety. It proves limited visibility. If you are driving at night and fog covers the road, the honest conclusion is not that the cliff is definitely in front of you. But it is also not that the road is definitely safe. The honest conclusion is that speed matters more when visibility is poor. That is the AMOC problem. The system is large. The instruments are young. The deep ocean is difficult to measure. The models disagree in important ways. The threshold is not painted on the water. And yet the mechanism is real. The feedback is real. The paleoclimate record is real. The projected weakening is real enough to appear across major assessments. So waiting for perfect certainty may be the one response the system is least designed to reward. Because a tipping point is only obvious after the fact. Before it happens, it looks like argument. After it happens, it looks like history. This is why the AMOC is so hard to talk about responsibly. Say too little, and you hide a real risk. Say too much, and you turn a physical system into apocalypse theater. The truth sits in the harder middle. There may still be time to reduce the pressure. There may still be time to stay away from the threshold. There may still be time for better monitoring, better models, better adaptation, better decisions. But there is no evidence that civilization has a simple repair kit for the deep Atlantic. No button, no valve, no emergency restart. Only prevention before the threshold, adaptation around the damage, and humility before a machine older than civilization. The time of the news is hours. The time of politics is years. The time of infrastructure is decades. The time of the ocean is centuries. That mismatch may be the deepest problem of all. Not that we do not know the machine exists. Not that we do not know it can weaken. Not that we do not know the consequences could be severe. But that the machine operates on a clock our institutions were never built to hear. And once you see that, the AMOC becomes more than a current. It becomes a pattern, a warning about the kind of world modern civilization actually lives in. A world held together by slow systems, quiet systems, systems nobody campaigns on, systems nobody sees on a normal day, systems that seem permanent only because they have not yet moved far enough for us to notice. The Atlantic is one of them, but it is not the only one. By now, the Atlantic machine should feel less like a current and more like a lesson. Not a lesson in politics, a lesson in structure. The modern world is not standing on solid ground in the way we like to imagine. It is balanced on systems. Slow systems, quiet systems, systems so large that no single generation built them, and no single generation fully understands them. The AMOC is one of those systems, but it is not the only one. Across the planet, the same pattern appears again and again. A system works in the background. People build their lives around it. It becomes familiar. Then familiar becomes invisible. Then invisible becomes assumed. And once something is assumed, the world stops asking what would happen if it changed. That is the dangerous part. Because many of the systems that make modern civilization possible are not linear. They do not always respond smoothly. Push a little, and they change a little. Push again, and they change a little more. Then, past a certain threshold, the response can become different, not louder. Different, a forest can absorb stress for a long time. Drought comes. Heat comes. Fire comes. Logging comes. Rainfall changes. At first, the forest bends. Then parts of it die back. Then the local water cycle weakens, because forests do not just receive rain. They help make rain. Trees pull water from the soil and release it back into the air. That moisture helps feed clouds. The clouds help feed the forest. But if enough forest disappears, the system can begin to lose the conditions that made it a forest. Less forest, less moisture, less rain, more stress, less forest again. That is the same shape, not the same machine, the same logic. A frozen landscape can hold carbon for thousands of years. It looks still. It looks empty. It looks permanent. But frozen ground is not just ground. It is storage. When it thaws, old organic matter begins to break down. Gases can be released. The ground can collapse. Lakes can form. Roads can buckle. Buildings can sink. Ancient stability becomes modern movement. Again, the system does not need to hate us. It only needs to follow its rules. Ice sheets work the same way. A large ice sheet is not simply a pile of ice. It is a moving body shaped by snowfall, melting, bedrock, ocean water, gravity, and time. At the edges, warm ocean water can eat at the ice from below. As the ice retreats, the geometry changes. More ice can become exposed. The surface can lower into warmer air. Flow can speed up. And once enough mass is lost, some parts may not return on any timeline a human society would call useful. The ice does not negotiate. It responds. Coral reefs work differently, but the pattern is familiar. For thousands of years, they have protected coasts, supported fisheries, and built living structures in shallow, warm seas. But they exist inside a narrow range. Too much heat for too long, and the partnership that makes the reef possible breaks down. Bleaching is not just a color change. It is a warning that a living system is losing the conditions it depends on. If the stress repeats often enough, recovery time disappears. The reef becomes less able to come back. The buffer shrinks. Then the system that protected coastlines and fed communities becomes a memory on the seafloor. Different systems, different physics, different locations. Same larger pattern, a hidden support, a threshold, a feedback, a delay between cause and consequence. And the most dangerous word in that sequence is delay. Delay is what makes slow systems so easy to misread. When a bridge cracks, people can see the crack. When a bank fails, the accounts freeze. When a storm arrives, the sky turns dark. But when an ocean current weakens, when ice loses mass, when a forest loses resilience, when groundwater is drained faster than it is replenished, the warning signs often appear as data before they appear as disaster. And data is easy to argue with. It is easy to say the line is uncertain. It is easy to say the model is imperfect. It is easy to say the system has changed before. All of that can be true. But uncertainty is not the same as safety. It is simply the fog around the machine. This is why the AMOC is such a powerful example. It forces a different kind of thinking, not headline thinking, system thinking. Headline thinking asks, what happened today? System thinking asks, what had to be true for today to happen? Headline thinking asks, who is to blame? System thinking asks, what mechanism is producing the pattern? Headline thinking asks, is this the worst case? System thinking asks, where is the threshold and how close are we? That is the difference between noise and signal. The noise is argument. The signal is structure. And once you start seeing structure, the news changes. A drought is no longer just a drought. It becomes a question about rainfall belts, soil moisture, aquifers, food systems, and atmospheric circulation. A flood is no longer just a flood. It becomes a question about land use, sea level, storm tracks, infrastructure, and risk that was priced for a different century. A crop failure is no longer just a bad harvest. It becomes a question about synchronized shocks in a global food market. A shipping disruption is no longer just a delay. It becomes a question about choke points, climate stress, energy flows, insurance, and the hidden routes modern life depends on. This is the larger pattern. Modern civilization is very good at optimizing systems. It is less good at noticing when the systems being optimized are sitting inside older systems that cannot be optimized by us. We can optimize shipping, but not the ocean. We can optimize agriculture, but not the rain. We can optimize insurance, but not the coastline. We can optimize energy markets, but not the physics of heat. We can optimize politics, but not time. And time is always there. Underneath everything, the time of the AMOC, the time of ice, the time of forests, the time of soil, the time of water moving underground, the time of carbon moving through the planet. These systems do not care about urgency the way humans do. They move slowly until they do not. They look stable until they cross a boundary. They absorb stress until they begin to pass stress forward. And once they pass it forward, the receiving system is usually us, our farms, our coasts, our cities, our prices, our borders, our assumptions. So if you have made it this far, I want to say something plainly. Thank you. This is not the kind of subject designed for quick outrage. It is not built for a 10-second clip. It takes patience to stay with a machine you cannot see, a risk that cannot be reduced to one villain, and a story where the honest answer includes uncertainty. That is exactly the kind of viewer this channel is for. People who do not want to be told what to think. People who want to understand how the world actually works. If that is why you are here, subscribe to Beyond the Noise. Not because every video will give you easy answers, but because the easy answer is usually where the noise begins. Here, the goal is different: to find the mechanism underneath the headline, to separate the signal from the noise. And the signal in this story is simple. The AMOC is not just about Europe. It is a window into the kind of planet we live on. A planet where the most important machines are often the least visible. A planet where stability is not guaranteed. A planet where some systems can be pushed and pushed and pushed until they stop behaving like the systems our civilization was built around. The world is not fragile in some sentimental way. The planet will continue. The ocean will continue. The ice, the forests, the winds, the rain, the heat, they will all continue in one form or another. The fragile thing is not Earth. The fragile thing is the version of Earth we know how to live on. The version with familiar coastlines, familiar winters, familiar rain belts, familiar growing seasons, familiar assumptions. The AMOC reminds us that habit is not the same as permanence. For millennia, the machine has turned. Warm water north, cold water down, deep water south. Heat delivered, climate shaped, civilization built inside the pattern. And now the pattern is being measured, questioned, modeled, debated, watched. The scientific debate is not whether the machine matters, it matters. The debate is how much margin is left, how close the threshold is, how fast the weakening is, how much time remains before prevention becomes adaptation. And that is where the final question begins, because the deepest issue is not only what happens if the AMOC weakens. It is what it says about us, that we may be capable of moving a 1,000-year machine without ever meaning to. A machine no king built, no president owns, no company controls, no generation fully understood. And yet, a machine that future generations may inherit in a different state because of choices made during ours. That is where this story ends. Not in the ocean, in time. So now the layers are visible. First, the map was wrong, or at least incomplete. Europe is not mild simply because it is Europe. Much of it sits far enough north that by latitude alone, it should feel more like the colder edges of Canada. Then the hidden machine appeared. Warm water moving north, cold water sinking, deep water returning south. A loop of heat, salt, gravity, wind, and time. Then came the arithmetic. Cold, salty water sinks. Warm, fresh water floats. Change that balance in the wrong place, and the ocean does not have to stop all at once. It only has to stop pulling as strongly. Then came the memory of the planet. The ancient record showed that the North Atlantic system has changed before, not as a movie, not as a weekend apocalypse, as a real physical shift, capable of lasting longer than kingdoms, longer than languages, longer than any human plan made for a single lifetime. Then the story crossed the ocean. It reached the American coast. It reached sea level. It reached food prices. It reached rainfall belts, monsoons, ports, farms, fisheries, insurance, and the strange truth that a current most people will never see can still touch the life they live every day. Then came the hardest part. There is no simple repair lever, no emergency switch in the deep Atlantic, no machine built by us that can easily restart a machine older than us. There is prevention, there is adaptation, there is monitoring, there is debate, there is time if the threshold has not been crossed. But the ocean does not move at the speed of politics, and it does not heal at the speed of headlines. That is the shape of the story, not certainty, not panic. Shape. A system works for so long that civilization mistakes it for permanence. Then instruments begin to notice a change. Models try to understand it. Scientists argue over the timing. Governments argue over the response. The public hears fragments. And beneath all of it, the machine keeps turning, or it turns a little less. That is the quiet terror of the AMOC. Not that tomorrow morning Europe becomes ice. Not that New York freezes like a disaster film. Not that one dramatic day arrives and explains itself. The real fear is more adult than that. A background condition changes. The world built on top of it does not change fast enough. And future generations inherit the difference. They may inherit coastlines that no longer match our maps, growing seasons that no longer match our farms, rainfall patterns that no longer match our reservoirs, trade routes, insurance systems, food systems, migration pressures, and national plans built for a version of the planet that quietly moved on. And they may look back at us with a question that is difficult to answer. Not because we knew everything. We did not. Not because the science gave one perfect date. It did not. Not because every warning was certain. It was not. but because the basic mechanism was visible. The machine was known. The risk was measured. The uncertainty was not empty. And still, the world hesitated in the space between evidence and consequence. That space is where civilizations make their deepest choices. Not in the moment when everything is obvious. By then, the choice is usually gone. The deeper choice happens earlier, when the signal is strong enough to matter, but still quiet enough to ignore, when the data is clear enough to warn, but not clean enough to end the argument, when the machine is still running, but no longer running the way it used to. That is where we are often tested, not by what we do after the collapse, by what we understand before it. The AMOC is a current, but it is also a mirror. It reflects something uncomfortable about modern life. We are powerful enough to disturb systems we are not powerful enough to command. We can warm oceans, melt ice, freshen seas, change forests, drain aquifers, raise coastlines, move carbon from the deep past into the living air. We can push. But we cannot always choose exactly how the planet answers. That is not immoral. It is a boundary. A species that learned to split atoms, cross oceans, wire continents, map genomes, and speak instantly across the planet may still be living inside machines it did not build. Machines that turn slowly. Machines that remember. Machines that can carry the consequences of one era into many eras after it. And somewhere, centuries from now, people may live beside a different Atlantic. They may not know our names. They may not remember our arguments. They may not care which headline won which week. But they will live inside the physical result. A shoreline, a winter, a harvest, a rain belt, a sea. And maybe they will ask the question that every generation asks of the people before it. What did they know? And what did they do with what they knew? That is the question the ocean leaves behind. Not loudly, not angrily, just steadily. Like a current moving beneath the surface. If this video helped you see the machine beneath the noise, share it with 5 people who would rather understand the world than be shouted at by it. Subscribe to Beyond the Noise for more stories about the hidden systems underneath the headlines, and leave a comment with the next subject you think deserves this kind of treatment. Because the world is not only made of events, it is made of mechanisms. And the ones we do not see are often the ones that decide the future.